Okay. In the name of God, the compassionate, the merciful. This is an unusual recording because on Fridays we usually just go through the code that is available in the book, and the gentlemen try to wrestle with it in their own environment, and I'll be here to help them with the wrestling. Now we are recording this time because in the Tuesday session of this week, there was a part of the book that I had planned to teach, but I failed to, and therefore I'm now going to do that now. So I would like to begin by sharing my screen for you. Okay, so this is the how do I manage this? Right, this is where we left, and just before I go through the remainder of what I had in mind, do we have any questions regarding this adder function? No. Okay. Okay. So me having watched my own recording, I know that I missed something about this function that I would like to bring up, and that's because later on I am going to use that again. So this practice of coding this adder function was an excellent presentation of the practice of TDD. You type something, you define it, and then you refine it, right? Now, that is why you see that when the book was going through the exercise, it began by first defining the type that it was later going to utilize. And once it was done with the type definition, then it was going through the definition of the function. And like we walked through the TDD of this function, we define it, we give it the type, we define it, and we refine that type, right? So that's the general practice we should have in mind. And the point about this book being called type driven, what is it? Is it type driven programming? What is it called? Programming? No, what is it? Type driven development in Idris is, the entire point is that it's trying to teach you through various examples that it goes through in the book, this process. So, and there is a talk, by the way, by Edwin Brady, the author of Idris and the author of this book, in which he says that this title and the slogan was something that he didn't have in mind until he came to publish this book, and it was someone from the publisher who promoted this idea and pushed for it until it became kind of the slogan of the book. Sometimes even the developers of the language themselves don't have a clear wording of what they are doing. This is an excellent instance, I would say. Now, let's get back to the science that we are delivering here. So, like I briefed you over in the previous session, the problem that we would like to solve is that we would like to have a printf like the printf of C, which is type safe. which means that if in the, let's say that we have a string that we are passing to printf, or we have a string in which there is this formatting label, that the $D, right? And then we are passing a number. Now we would like Idris to stop us if, for example, in the passing of you know, a value or a variable, or generally an expression, to printf with this label, we pass something of, let's say, type string, or I don't know, type bool, or things like, which essentially cause a type mismatch. So we would like Idris to issue a type error if we pass the wrong an expression of the wrong type to correspond to the wrong label, right? Now, so in order to solve that problem, you know, this is a TDD world, right? And as you do that, so the first thing is that you provide the type, then you do the definition, and then you refine the definition, right? Now, so that is exactly the reason why we begin by defining a format type. Now, this format thing is not exactly the labels here, you see, right? It's kind of you know, he calls this, I can't highlight this with the, let me see. Oh, there's no, okay, I can't do that with my current pen. But anyway, so the entire idea is that we would like to oh, James is we would call what is in this box the formatting, and that is not just you know, a string or a label. It can be a string consisting of several labels and several layers, right? Hello, James.
Hello.
Yeah, good to have you.
Sorry, by the way, my internet's been not working, but Nils managed to fix it from afar.
Oh.
He knew what to
Very
do
good.
in my accommodation to get it up and going again.
I had the same problem when I lived there.
Oh, I see. That's how you can telework the issue out.
Yeah.
Okay. Well, fine. Now, good to have you again, and if someone can also bring Sunder back to the scene, I would highly appreciate that. Now, so what I was saying was that the view of the book on the formatting is beyond just the labels, and you see, we being in a functional programming language, the view that Edwin Brady is promoting here is a recursive view, and so he has these this recursive type, right, that he has for description of the formatting. It's the way he sees it is that, okay, it's either a numbering label followed by more formatting. So it's a number of a format, right? Or it's a string followed by more formatting, or it's a literal and then a string followed by more formatting, or it's that there is no more formatting, so we've come to the end of the formatting string, right? As you can see, this is just a type, right? This is a data type, it highlights the type that we would like to work with. And one thing which is interesting about this mindset is that if I show you the final picture, right? The final picture is something like this. We would like to have a printf which has some formatting in it, right? Or one that a printf that has some formatting and takes some values, right? Now, as you can see, there is no formatting type as we are showing here in what you see in the final picture, right? Now, that is what the book refers to as the intermediate types. So that's this box here, right? Now, so the book explains, and I think that the explanation is quite sweet. The book explains that in the process of TDD, you often end up, solving the problem by transforming, taking several steps of transforming one data type to the other. By doing such, you kind of gradually massage the problem to its solution, right? Now that mindset requires this concept of the intermediate types. So those are types that you will not see in the end solution, but as your solution is going to work it out through the process, it will use these intermediate types, right? So that's the idea of intermediate types in general. Now the book also says that sometimes when you want to play around with, not sometimes, but it's the one more reason why you would want to have intermediate types is because you want to have descriptive type names. So if instead of the format thing, for example, we would have wanted to work with a type that takes a string and returns a type instead of a type that returns takes a format and returns a type, for the matter of code reading and for the matter of acquiring help, automatic help from the compiler, you were providing less semantic information, right? Whereas by giving it a meaningful name, you're both extending your courtesy towards the human code reader of your program, and you actually help the compiler to provide for you, or the editor to provide for you, automatic support for TDD, right? So this is a mutual benefit. Now, so let's take a look at this very instance here in terms of ASTs. By the way, how many of you are familiar with the concept of AST, abstract syntax trees? Okay. So given that Daniel was not familiar with that, I'm going to give a very brief explanation. So you see, when you have an expression like x plus y, right? And that is an expression. And that expression has sub-expressions. There is x, there is plus, and there is y, right? Now, if you want to show that using a data structure that you can feed into the compiler, because the compiler would like to analyze it, let's say, for example, for code generation, right? Now, the matter of code generation takes place in several passes. So for example, the compiler needs to make sure that there is no syntax error in the expression that you feed into it, right?
All right.
And then once there is, there might be, let's say, referrals to the other places in the code, right? So once the compiler is done with this part, with this expression, it needs to jump to somewhere else and fetch something and come back, do things of like. Another pass might be optimization, right?
Mm-hmm.
So, for example, if it for using some sort of analysis knows that y cannot be anything other than 0, x plus y simply becomes x, right? Now, in order for it to be able to work with these passes of compilation, it gives itself some intermediate representation of x plus y that we, the human beings, like to think of it in terms of a tree. So that's a tree. The root of it's a labeled tree. The root of which is plus, and the left branch of which is x, the right branch of which is y. Right? Now, this tree represents your program, in this particular case, your expression, in a way that relates to what is called the abstract syntax of your programming language. It does not relate to what is referred to as the concrete syntax of your language. Now, so you probably are familiar with some languages like the Lisp family of languages. If you want to do x plus y, you put within parentheses plus, then space, x, then space, y, right? So you see, the syntax in which the programmer programs is one thing. The syntax in which the compiler stores what it gets so that it can perform several rounds of analysis on that is different, is another thing, right?
Okay.
Now, the one that the programmer programs in is called the concrete syntax, right?
Right.
The one that the compiler stores for its own massaging of the program is called the abstract syntax.
Okay. Okay.
Now that abstract syntax, when you have an instance of that abstract syntax, is represented using a tree, which is referred to as the abstract syntax tree. Okay. Now, so here is an instance of that entire story. This is an instance of a concrete syntax. Right? Now, this is what the programmer produces. Now, internally, the compiler stores the same piece of code like this. And you see these arrows, they are not arcs of a tree. This is the book trying to show the production of the abstract syntax from the concrete syntax, right?
Yep.
Now, so the highlighted part is the abstract syntax, and if you would like to give this, I wish I had, and now that I have my Remarkable, I wish I had shared this with my Remarkable, because then I can have a better command of the highlighting and all that. Maybe I should do that. So I'll finish this, and if you don't mind, I'll pause the recording and change the sharing. Okay.
All right.
Now, if you want to show the abstract syntax that I am highlighting using trees, then you would see that this is a tree which has the label string at the top, then a label lit, which has two sub branches, one for the literal equal sign. Is that an equal sign? Yes. And the other one for another tree which has number on the top, and then a single branch for end. Right? So this is what I meant by abstract syntax tree. Now I am going to pause the share now. Do I pause the recording? Pause record. Okay, so we were talking about let me pick the right pen. Oh, why don't you see the copy? Hello? Ah, that's correct. So we were speaking about the AST of this, and I said that this is a tree with str at the top, and then a lit, and then the lit itself, sorry, has two subtrees. One of them is an equal sign, and the other is a number with end, right? So this is kind of the abstract syntax tree presentation of that same expression presentation of the concrete syntax that you see here, right? Okay, now let's move to the right. I think at this point I need to go to the Visual Studio. Okay, so the idea is that we would like to have a function which, given a format, gives us the right type for that formatting that we have in mind. So we have an AST that is the format thing that describes in an intermediate way what we would like to do, and now we would like to work out the Idris types that make that happen, right? Now, in order to do that, so the book does is that it says, okay, now I would like to have a type which explains to me the type of the printf expression that I'm going to get. All right. Now, so one thing that I have done extra to the book is that I have provided the name directive for the data type format, and so what that in particular is going to help us with is the process of TDD. So now, if I just add clause and save, you see first of all that the name here is FMT, whereas if I didn't have that, then would have been, I think it would have been X or something, right? Now, And the thing is that if I now case split on it, you know, the recursive, these don't have names, right? Neither the format nor the string have names, right? Now they have good names here. There is, when there is a formatting, there is FMT. When there is a string, there is str. And this one comes from the str, the string type of the built-in string type of you know, Idris. I didn't do that one, but it's for similar reasons. Let's save. And so what we would like to do is to say, well, if the printf has a number format, then we know that a number should be collected, and we should go to the remainder of the formatting, right? And that's the type. So when you have number followed by the rest of formatting, it means that the runtime environment should work with a number that is given to it, and then do the rest of the job of the typing of it for the rest of the formatting, right? So that is why, you know, with this being given, the compiler can also work out, if you go for the right. No, it can't. Not. I've seen this. Okay, I was wrong. Right. Okay. Well, anyway, so the idea is that we should oh, sorry. So this is a function that takes an integer and does something else. Let me do it this way. I can get some help here. So let's keep this, right? And then do this. Right? Now, if we do that, then well, let's take a look at the typing. So we have already worked out some part of it. We are expecting a type, right? Now, the types that are available need to be acquirable using the contextual information, or at least if sorry, I retract. If Idris can work out the type that we are going to return, and we have already provided parts of it because we have provided a function type, right? The remainder needs to be worked out, if it can be worked out automatically using the contextual information. So let's see what contextual information Idris can write. This one is correct, right? So, but this was also available before we doing the function type, right? Because this is an available type. We know that this is you know, the format, the FMT is a format, and we know that if we feed FMT to printf type, we are guaranteed to be returned a type. So that is how it can work out printf type of format of FMT at the very first, right? And that same reasoning is valid after us, you know, introducing the extra indirection with the function type. Now, Mikhail, would you like to work out the second one for me, please?
Isn't it just the same thing, but except for the I in its string? Or
that is true. That is true, because a right, instruct me.
parentheses.
Okay.
Inside you can write str,
Yeah.
semicolon,
Semicolon.
colon, sorry.
Okay.
Capital STR for the tie.
Yeah.
Oh, it's string. And the arrow pointing to the right.
Mm-hmm.
And printf type of FMT. Like
Okay.
the one.
Right. Okay. Given the time lady, I'm gonna get the machine do the job for me. Okay. Niels, please instruct me on the next case.
Yeah, I'm unsure with the string part.
Mm-hmm.
We can see if it will tell me what to do. If you just
Okay.
try to, yeah. Hmm.
Well, let me give you a hint. Well, first of all, your cheat sheet is down here,
Yeah.
right? So that's one thing. But let's work out why that is what we want. Okay. And to that end, I would like to get back to the example that we had here.
Mm-hmm.
So you see, we are at the moment talking about this one,
Yeah.
right? Now, if you pay attention to that, there's this label
Mm-hmm.
that shows up here in the typing,
Mm-hmm.
and there is this label that shows up here in the typing, right?
Mm.
And what that means is this part of the formatting string is disregarded.
Okay.
Right?
Yeah.
So even though it does participate in the final string that we would put to the screen, right?
Mm.
This part of the formatting string does not participate in the typing.
Yeah.
Okay, and for that reason, it is that the automatic, in this very case, the automatically generated piece of code is what we want, because we want to disregard, for the matter of typing only. This is only the typing, right? For the matter of typing only, we would like to disregard that string argument. Okay.
Right. Yeah.
Now, Daniel, please guide me through the fourth case.
Well, I think the book specifies that for printf,
Yes,
we want to return a string.
Right. Okay. Yeah. Why would you think that that is correct?
Why would I think that's correct?
Yeah.
Yeah. Well, that's what the.
Right. Okay. Let's get back to this picture. Now, I reckon that I should have shown you this picture before going to the code. My apologies for not doing so. you see, so what it wants is that, you know, this bit is treated as a string, right? Now, this bit is treated as a function that as a type from int to string, and this bit as a type from string to int to string. And so the case that I asked you to help us with is the very first one. So it's this one,
Right.
which is the place where we are dealing with no remaining formatting, right?
Mhm.
So when there is no formatting still required to be processed, what is left is
String.
So the string.
correct, right? Like it is with this case. Okay, so that is the reason why, in this case, string is the type that we would like to return. Now, unfortunately, string is not one of the options that Idris can automatically figure out. Okay, so I'm going to manually put that in. Okay. Now, right. So again, like the adder case, what this printf type has done for us is that it has performed the type level calculation for the printf formatting, but it hasn't still done the job of producing a the functions themselves that perform the stepwise dealing with the digitals and with the strings, right? We have two. By the way, I stated this the previous time, but I forgot to also state it that out of the many labels that C supports for its printf, we are here only going to work with the %d and the %s, right? So that's the reason why we only have like two labels to consider. There is the integer and there is the string, right? So okay, now so armed with the printf type, now we would like to have a function which takes a format and kind of works out a string accumulatively, which will eventually be shown to the on the screen, right? Now, so that's what this printf fmt is. It's that function which is going to you know, traverse the formatting that we get, and it will, like I said, cumulatively build the string for us. So Jan, would you mind guiding me through the
Sure.
TDD of this function? Yeah.
Let's do a case split. Or is it the add clause it's called? Yeah.
Okay.
And then the case split. And then save.
Then save. Very good. Now then you case split on what?
I suppose the format, since you want to have each of the cases for the formatting.
Absolutely.
To return your printf type, since that's what we depend on.
Yes, very good. Indeed. So.
And
Okay.
yes,
Good.
then we start building our string in the accumulator.
Yeah.
Uh,
This is where the TDD becomes even more interesting. Behold, okay.
That is right click on the question mark if it'll allow us. Maybe save again. Or
I have already done that.
oh, okay. Yes, good.
Okay. So I kind of anticipated your answer. So I have already highlighted one of the holes. Right.
Let us look
Okay.
at the whole.
Like you would like to observe
The
its
light.
type or okay. Now
Or will it
I think even watching the
oh well, yeah, then we'd have to have a lambda.
Yeah.
With this
Watching
type.
the type of it is going to render some hope, right? Because Idris can figure out that this thing has to be a function of this type, a function from integers to printf of printf type of the rest of the formatting. Right now, that gives me personally high hopes in that it can actually work out some of the details at least for us. Would you like to try that? Yeah.
Yes, of course.
Okay. Okay, which one would you choose?
Fourth one down.
Very good.
Oh no. Oh, no. Oh, yeah, no, that's right. That's right. Oh. Well.
You see?
We are
It
missing
can work out. Yeah.
The addition to the accumulator, but that's about it.
Absolutely.
Because
Absolutely.
we'd like to grow that.
And how would you do that?
Concat plus show, and then I, since I is the number we want to show.
Yes, that's right. So you see, it can work out from the typing information that we have provided. It can work out that this has to be a function from an integer, and this, I think it can work out that this has to be an integer because we have given it this type. And given that we have named I here, it has chosen to call this
Lambda.
the parameter to that lambda I, right? And so then it can work out, yeah, fine. So I am going to probably recurse on myself. It's a printf FMT, and that requires an FMT. I have already consumed the number thing with this I that I take in the arguments. What is remaining is only this FMT. So probably the first argument to this printf recursion, printf FMT recursion, is FMT, which I have here. Right? And then, okay, what else do I need? Well, I need a string. What string is available? ACK is available. Right? So that's how it came to that conclusion, which was not exactly what we wanted, but very close. Yeah, very close. Yeah. James, would you mind doing the rest, please?
Sure. So I'm not seeing the hover over for the type. Do you need to say?
Okay.
Oh, there we go. So it's going to be a lambda. So
yeah.
Oh, we could look at the options.
Yes. Okay.
Oh, so one of the bottom two look interesting.
Okay.
Go for that one.
All right.
It's not quite right though.
No, it's not.
We need to concatenate I guess where stir with ACK.
So is it this one
Yes.
or is it the other way around?
No, it's that way.
Okay, good. Now I'd like to ask you to explain to me why the compiler, well, that's not quite the compiler, but Idris, the editor, was right to also suggest this one.
Because both ACK and STR are of type string, and it's sort of type blindness in a way. It doesn't know which
Yes.
string to stick in there.
Right, that's
So-
right. That's
And the answer is
absolutely
neither.
right. The answer is
Both.
neither. Yes, yes.
Yeah.
The answer is neither. But the they are equally
With programs.
yes, they're equally typable. Right? They're equally typable. Okay. Now James, could you please also go for the remaining cases?
Yep. So we'll look at the options again. The fill out options. I'm trying to
Okay.
get in the habit. I don't think any of them are maybe one of the bottom ones.
Which one would you like to go for?
The top bottom one. I don't think it matters so much. I mean, the bottom one's closer, but it's fine. It's a good starting point.
Okay.
So we want to change STR on the right hand side to ACK plus STR.
Okay.
Yep.
Very
And
good.
then finally,
Now, let me just stop you there, Mikhail. I have the impression that you're not entirely following.
I understand most of things. The the line you're on now confused me a bit.
What confuses you?
Yeah, that's what I'm trying to figure out.
Okay.
How the literal works, I'm guessing.
Yeah, that's a good way to phrase it.
Let me maybe show you this. So, is your confusion about this case?
Yeah, yes. The literal is the element you drop, right? The part of the string that's not done.
Well, what we drop is when we are working the typing only the typing.
Yeah.
Right? And we only drop this part. So let me just change the color. This is the portion that we're dropping. Right?
Mhm.
And that's only in the typing. It's not that in the ending instance of string that we return, this number literal is not included. It will be
Okay.
included, right? But that inclusion needs not to show itself in the typing, because we need to read a string. We need to, which is here. We need to read an integer, which is here, and there is nothing to read here. That's
Okay.
why the literal itself does not show up in the typing, because everything which comes before the final right arrow string contributes to the things which are going to be read from the arguments that we pass to the printf function. Right? Now, let me go back to the very end of the story. Oh. Now this is an exercise that you will do, which extends what we have done, what we are doing for the cases of characters and doubles in printf, right? But suppose that these were already supported. What we want to do is that we want to be type safe on the reading of a character X for and %C and 24 for the formatting label of and %F, right? So that means that as we are processing, as we are processing, come on. This part, right, we should be producing a function of this type. Which is why passing of X to char and 24 to double is lawful. It type checks. Right? Now, if it would have been that somewhere in between, or probably some other place, let's say, if it would have been that, let's say, between the two of these, let's say here, I had a piece of text, let's say X equals, right? Now that piece of text would not, for the reasons that I just explained, participate in the typing of this part, right? But it will produce, so it would have been, you see this here? It would have been this with an equals in between the character X and 24. Right? So it doesn't, the matter of what comes in the typing is not necessarily reflected entirely in the contents that we're going to produce. Right? Now,
Okay.
this part does participate in the final instance of the string that we will produce, but it will not participate in the typing of that string because it still is the string. Okay. Fine. Okay. Let's get back to James. And
Yep.
the only remaining case.
So it should be able to fill this one out, I think. So if we look at the options,
what should that be?
Well, if you look at the options, I think it will tell you because it should be ACK, but it'll fill that out.
Because
Okay.
ACK is the only string, and
Yeah, there it is. Magic.
Right. Okay. Because ACK is the only string, and Jan, you were
and is
saying?
of type or printf
Okay, so we
Type
have
for and
promised
is a
that-
type string.
yes,
So those two.
yes, right. So we have promised to return a printf of a format, right? And printf of end is a string,
Is string.
and what strings are in the context?
Ack.
ACK is the only available. Now, it could have been that our logic would have been that instead of ACK, we wanted to have, let's say, this string, right? That's fine.
That is also
But that is something that with the available contextual information is
So
not
you-
deducible, right? That's why if that would have been the case, the editor would have not been able to infer that logic of ours. That's in our brains. It's semantics that the machine cannot understand. Right? Now, okay. Now, this is a good time for a joke. And I have already exhausted a lot of you. Let me see. Niels, would you mind?
Why couldn't or why can't a bike stand up by itself? Because it's too tired.
Right. Good one. Thank you. Thank you. That was good. That was good. Yeah. Are you now a little less tired so we can continue?
Yeah, sure.
Okay. Very good. So the next thing we would like to do is that, okay, we have now got something that given a formatting can accumulate the string that we would like to put on the string on the screen, right? But we don't still have the we haven't still worked out how, given a string of formatting, so how given one of the how given one of these, right, we make it to the structured data type format that we have been working with, right? This is raw string. This is not an instance of that data type format, right? So our next plan is to parse this into a format object. Now, to how many of you was that use of the term parse makes sense? How many of you are familiar with the right? Okay, so you all have seen compilers and you know that's what the parsers do. Okay, very good. Now, so with that in mind, now we would like to have a function called printf fmt. Oh, sorry. My apologies. Yes, that's right. So yes. So given a raw string, which usually we deal with using the type class string, right? Now let's say that we have now detached the characters of that string and produced a list of okay, this is the second yawn that I have observed. So Niels was now yawning. Yes, thank you. But James was the first, but you watched the recording and you notice it.
You've missed a few, I believe.
Yeah.
I might have, but the first that I observed, right?
Good.
The first that I observed was from James, but I didn't pick up on it. It's yeah. Anyway, I did pick up on Neil's. Yeah. Right. Now, so back to business. We would like to have a function which, given a list of characters, traverses that list and produces for us an instance of the format data type. Right? Now, who hasn't done TDD for us today? I think no one. Niels, have you done?
Yes, I can start if you want to.
Okay, go on.
Yeah. So you have saved, so you can click on the light bulb.
Okay,
and
very good.
Add clause.
Okay.
And then save.
Saved, yes.
Yeah.
Okay.
And then you can case split on excess.
Very good.
Yeah. So if it's can you hover over the first hole, please, so I can see see the
This is, I am doing that. Maybe
okay.
I should just increase the font. Oh, come on.
No, but the or is it because I didn't say no? It was saved. It just doesn't want to. Yeah. So try to. Yeah.
Put the curse there. Yeah.
Yeah. Intro end over
Right. Okay. Okay. Good one.
Yeah.
You know, this is the list of the options is quite huge.
Yeah.
And the reason is that, you know, all of these, you see, it's trying to kind of make it bigger and bigger and bigger. You know, all of these are formattings which are producible using the contextual information.
Yeah. And yeah.
Right. And it cannot figure out the fact that what we want is only just one thing, which is the end. That's our contract. You know, that's our convention. In our convention, when we have an end formatting, it means that we are done. Right?
Yeah.
And it's the other way around. If the string is empty, we show that in the formatting world using an end. Right? So that's why this is, as you pointed out, the only correct option.
I like our printf type has isn't there's like only one case that's like non-recursive, and then that's end.
That is true.
Wouldn't it make more sense for Idris to have like the terminating case higher up on the list of priorities of choices?
Like that it matches the arities of the constructors.
Yeah, because you can like
Right. I think let me try to paraphrase your question. So I think you were speaking about this being
no, I was talking like because usually use or this might be me not knowing the difference between the expression search and an intro.
Okay.
Because on the expression search bit, I feel like having end as a option, like just end before nesting it in the other makes more sense. like
Right.
having it higher up in the list with like, because it's the least amount of wrappings, if to put it that way.
Right. I think you have a point there.
It seems like
But-
Idris. Oh,
Go on.
It's-
Go on.
it seems like Idris simply took the ordering that you gave it when you declared the type.
Yeah,
That,
maybe
that is
since,
true. That is
since
true.
number is used way more than STR. So if we put printf type first instead of line 11, put it on line 8, would it then prefer?
I imagine.
Okay.
I imagine. But what's more than that I would like to point out is that you see the difference between intro and expression search is that these are what are referred to as open terms, whereas the expression search produces closed terms,
Okay.
right? Now,
But in the case of the end, it's closed.
that's right.
Yeah.
That's right. Because that's the only type constructor of format that even though you are so let me put it this way, because end is the only nullery type constructor of format. That's the reason.
Nullery.
Nullery
Like-
is the one that does not take any argument,
Okay. Yeah.
right?
Yeah.
But anyway, these are all just type constructors. So it's introduction here is one application of the data structures, leaving as many holes as the arity of the type constructor requires.
Okay.
Now, in this case, in the case of end, right? End does not require, because its arity is 0, it does not require any extra holes,
Yeah.
right? But still, this is an introduction. It's not that Idris tried to produce a closed term, right? It only
Listed the possible type
constructors.
Yeah.
Correct. It only produced a nullery type construction.
Yeah.
Right. There is a slight difference.
Yeah.
Right. Okay. So this was end, and I tell you what, the rest of the cases are not that much of a TDD, so I'm just gonna copy paste them over.
Yeah, I imagine
right.
Can't figure out that we want to use percent and D.
Yeah. Yes, correct. And so I would. Right, Mikhail raised his hand.
Yeah. Just one question on the case matching
Please.
there with the percentage and D. Could you have
Yeah.
case matched on the string percentage D as well? Or does it have to be on the characters?
Well, I don't know.
In the input is a list of
But
characters.
I think
Yeah. Okay, yeah, that's possible.
yeah. So I think what she's saying is that could have we just left it to be in the world of strings and then performed a matching on strings?
Yeah, like you can do it in Haskell, but
that is not possible.
you can do it. You can do it in Haskell, I think, but that's because
Right.
list of char is the same as string.
Yes,
Yeah.
yes, correct. Yeah. Okay. Now, fine. Then the only thing that remains, as I have lost track of time. Ooh, we're almost at the end. Oh, okay, this went slower than what I was expecting, but I think that it was important. Okay, so now what we have is that we have our printf is going to receive. I'm going to let me just call this. I'm going to rename this as format string. Or, yeah.
We're typing at the end of printf the to format unpack, or
Oh.
no?
No, but something here changed without my notice. Ah, I see.
Yeah.
I think it didn't like the underscore.
No, good. At the end of the line on 29, you're using F and T, but you haven't.
Right.
Yeah.
Oh, thank you. Thank you for saving me. Yes. Okay. So right now we have all the building material for the function printf itself. It is supposed to receive a formatting string and then give us a function, right? Like what we were doing here, you know, when you have a printf of a formatting string, right? You receive a function that is expecting the right types. That's where the type safety comes in. Now, what is the type of that function? Now, here is another beauty of dependently typed programming when it comes to type level programming, right? Now, the type of that function, first of all, needs to be worked out using printf type, right? Then, given that this is a string, we have to have a way of producing a list of characters out of that, which is this part. So this is unpacking of that string.
What does unpack do?
That's a built-in function of Idris. It's already in the prelude, right? Which takes a string and produces a list of characters.
Oh, right. Of course.
Yeah. And now armed with that, we can pass that to toFormat to get a format, which is this one. And once we are armed with that, we can pass that printf. We can pass that format to printf type to get the right type, which in the case of this instance is a function from char to double to string. Right now, the interesting thing is that we didn't really need to state the value level here, because with the available typing information that is already produced at the type level, the compiler can already work out the variable level, the value level, right? In fact, we have already put the logic of what we want at the type level. That's how it can figure out the value level. Right. Now, we don't have enough time to go through the you guys wrestling with the code on the spot. And I just wanted to say that in the next chapter, sorry, in the next section, the book goes through the data store example. In that example, there are a number of things that you get only here in the book. One of them is discussion on the fixity of user-defined operators and also their precedence, right? So there is more than just how to do real world here, right? There's that. The other thing that I wanted to say was that at the very end of this chapter, the book talks about nesting of maybes, right? And so you see, for example, is it here that it does a case split after? No, it's not. Right. This is one instance, yes. So you have a case split at the top level, and then you have another case split, and then you have another case split. When these case splits are in the level of maybes, because maybe is monadic, and this is me supposing that you guys know what a monad is. It means that you can utilize the bind operator. And Daniel, this is somewhere you can get help from James on. And accordingly, let me try to get to that. Accordingly, this nesting of maybes, so X and Y can both be, they are both maybes, right? So there is a case split on when X is nothing or it's just something, and there is a case split afterwards on when Y is nothing or just something. Now you can utilize the do notation because there is a usage of the bind operator that you can use, which then means that you can further pack that into this beautiful do notation version of the same horrible nesting of maybes. And that's all because maybe is a monad, right? The famous optional monad. Okay.
Co-product with a unity, or co-product with a unit, sorry. And maybe is the co-product the functor that gives a co-product with a unit. The unit is nothing.
True. That's true.
Yeah.
Yes. Yeah. So that's us for this week.